How do you organize large Simulink project files? Imagine working on a complex electrical system model that spans hundreds of files. Keeping everything neat and accessible can be a challenge. Today, we're going to look at how to keep large Simulink projects organized and easy to manage. First, start with a clear folder structure inside a Simulink project. Create separate folders for models, libraries, data, code generation, tests, scripts, and documentation. This way, each type of file has its own space. For example, put all your Simulink models in the Models folder. Use hierarchical organization with subfolders for different subsystems or sections of your project. Libraries should hold reusable blocks or components you plan to use across multiple models. This promotes modularity and saves time. Store input data, calibration files, and parameters in the data folder. Keeping data separate makes updates easier. The code generation folder is for generated code and build artifacts, like production code or cache files. Create a dedicated tests folder for unit tests and system tests. This helps verify your models work correctly. Scripts used for automation or analysis should go into the scripts folder. And all design documents, specifications, or requirements should be stored in the documentation folder. This keeps everything linked to your project and easy to find. Using Simulink Projects helps enforce this structure. It manages project-specific settings like MATLAB paths, startup tasks, and environment consistency. You can tag files and folders with custom labels, making searching and filtering simple even in large projects. Componentization is key. Break down big models into smaller subsystems or referenced models. This speeds up simulation and makes testing easier. Design interfaces carefully, often grouping signals into buses to reduce clutter and improve clarity. Apply consistent modeling guidelines across your project. Use uniform naming conventions, signal handling, and block usage. This is especially important in electrical engineering projects that follow standards like ISO 26262 or DO 178 degrees Celsius. It helps with traceability and verification. Integrate version control systems with your Simulink project. This allows tracking changes, managing collaboration, and reproducing results. Automation scripts can check models, run tests, and build code automatically. Regularly review your models and refactor them to reduce complexity. Split overly large subsystems into smaller parts and make signal flows explicit. This keeps your project manageable as it grows. In practice, this organized approach supports electrical engineering workflows like generating production code, creating hardware-in-the-loop simulations, and managing large system models efficiently. By following these steps, structured folders, modular components, consistent rules, and project management tools, you can keep large Simulink projects neat, collaborative, and aligned with your engineering goals.